In this video, we are going to apply Kirchhoff's rules to two problems. Okay, the first one, in the circuit shown in the figure, find the current in the 3.00 ohm resistor and find the unknown EMF E1 and E2, and finally the resistance R. Now, first, as I said, we are going to draw the circuit. We are going to label the currents. We are going to say which loops we are considering. Here I labeled this one is going to be the upper one as 1. This is 2, and this one 3. For the currents, I decided I'm going to have current here going through R to be I1, and here I decided I want to have I4 going through this EMF and I5 going through this one here, and I3 to go through this one, and I2 to go through this resistor. Now if you look at the junction rule, you are going to find that I can say here that I is going to be the current that is including I2 and I3. When it's going to come here, the current in the 3 ohm resistor, you're going to find that I3 is going to continue here and I2 they're going to continue here, and then they're going to both of them they're going to be adding up to 8 amperes. Why is that? Because I know from the known things that I1 is 2 amperes, I2, which is the one through the 4 ohm resistor, is 3, and this one is 5. Then I added 3 plus 5 equals 8. Now I'm gonna apply, remember we said we are going to travel. Now loop 1, it is the upper one, and here I will say I am traveling in this direction, then I am in the direction of the current, then this is gonna be minus I1R. This is the potential difference across R. And then I'm gonna go here. Okay, I'm gonna continue. This is my loop here. I am going from positive to negative. For a battery, then it's gonna be negative EMF1. For this one, I am going from negative to positive. Therefore, this is plus EMF2, and this all equal to 0. I can here apply the also loop 2. Okay, loop 2 is here, and then I know that I'm gonna go in that direction. Look here, my direction for that. I can go from negative to positive for EMF1, then this is EMF1, plus minus, I will go through this resistor in the same direction as the current, then it is the value of the resistors times I2. And then here, I'm gonna go through that resistor, which is the 3 ohm, which has the two currents, I2 plus I1 times 3. And this always equals 0, and this is gonna be negative. Now, from this here, you know that I2 is known, I3 is known, then I will be able to calculate EMF1 from these numbers, and it's gonna be 36 volts. I can also do loop number 3. Loop number 3, I'm traveling for loop number 3, which is here. I am going from positive to negative for EMF2, then it's gonna be negative EMF2 plus I2 plus I3, because I am going this way along the 3 ohm resistor, and therefore it's gonna be positive. And finally, I will go against also the current in the 6 ohm resistor, and therefore it's going to be plus 6 ohms times I3, and that equals 0. Also here, I can do the the calculation, and I have calculated E2 to be 54 volts. Now also remember, we did find this is loop 1. Okay, then this is loop 1, okay, when we apply Kirchhoff's, and then therefore we are going to be able to calculate R as EMF2 minus EMF1 divided by I1, and that is 9 ohms. Then I was able to calculate the current in the 3 ohm resistor. I was able to calculate the unknown EMF1 and EMF2, and also the resistance R. Okay, let's go for another one. In the circuit shown in the figure, find the current in each branch and the potential difference VAB of a point A relative to point B. This is my circuit. Again, I labeled this is like, I like to have this is like A, B, C, D, E, F. So the labeling is gonna help me in naming my loops. The first one, this one, it is called the junction rule, and that one, whenever I have a junction, like in here, I will be able to say that I1 is entering the loop, and I2 and I3 are leaving the junction. I1 is entering the junction, I2 and I3 are leaving, and therefore I1 equals I2 plus I3. Then I'm gonna consider A, B, C, F, A. A, B, C, F, A. Then that is loop number 1. And then I will go through first EMF, which is going to be plus EMF1. And then for R1, which is this one here, I said negative I1 R1. And then is going to be going this direction for R2, then is going to be with the current, okay, which is I2, then negative I2 R2. And then I'm gonna go again, like against the polarity of the battery from positive to negative. Then there is negative EMF2. And then here for this one, I'm gonna go also against, I'm gonna go with the current, and therefore it's gonna be minus I2 R3. And finally, for the 3 resistor, I am going again with the current minus I1 R4, and this always all equals 0. What I can do here is I can factor I1, because these two terms, they have I1, and I can factor also I2, and then having my EMFs, transfer to the right. I know that I have all these values here, which I will be able to substitute, okay, for R's and for EMF, but I don't know I1 and I2 still, they are going to be my unknowns. For any equation that has two unknowns, we should have 2 equations in order to solve for the unknown. Therefore, I'm gonna go and consider the second circuit, the second loop, and that is this one, F, C, D, E, F. And for that one, I applied again the rule, then I2 R3. I am going, okay, where is my I'm going this direction. Therefore here, I'm going for I2 R3, and then EMF, because I'm going here, and then plus I2 R2, and then negative I3 R5. Again, I can collect the terms that they are going to be the same, okay, and factor things. This is algebra here, and then finally I will get this equation for I1 and I2. Also, I have this equation that I derived from loop number 1. Therefore, I will have this second equation here. Now, what we can do here is I need to solve these simultaneous equations, either using elimination or substitution. Here, usually I use elimination, therefore, I multiplied here by -2. Then this one is going to be 10, and that one is going to be -10, and that one is going to be +10. And then I added the two equations together, and therefore I was able to calculate I2 to be 0.20 amperes. Again, I want to find what is I1, therefore I did use this to substitute in, and from that I was able to calculate I1 to be 0.8, and then I know that I3 is I1 minus I2, then just I subtracted the two values. Now the second part, it is asking us to calculate what is the potential difference VAB of point A relative to B. Okay, therefore I need to go through this route here. And what I did, I said plus EMF, VA plus EMF minus 2 times I1 minus 1 ohm times I2 minus 5 volts. It should be equals volts, the voltage at B. Okay, then you are going as if you're applying also the same rules, but you're gonna start from voltage at A and then end up to that equals voltage at B, and from that I will be able to calculate VAB as -3.2 volts. Okay, this is for Kirchhoff's laws.